The big picture in 2025. The world is in the midst of a seismic technological shift driven by generative AI. This isn't a future promise, it's happening now. 1 in every 8 workers around the globe now uses AI monthly, and the growth is explosive. Applications built on AI are already generating billions of dollars in revenue. The technology is advancing at a blistering pace, with key metrics like model intelligence, cost efficiency, and the amount of information they can handle, context windows, improving more than tenfold every year. The very nature of knowledge work is being transformed as AI copilots and autonomous agents begin to tackle complex tasks once reserved for highly skilled professionals like engineers, lawyers, and designers. This wave is creating a new kind of company, the AI native organization. These companies are leaner, faster, and built around small teams of versatile generalists empowered by AI, blurring the traditional lines between roles like product management, design, and engineering. While the economic landscape is still taking shape, one thing is clear: we are at the very beginning of a new industrial revolution. Chapter 1. How we got here. This AI revolution was ignited by 2 fundamental breakthroughs. 1. Self-supervised learning. This technique allowed developers to train AI on vast amounts of unlabeled data from the internet. Instead of needing humans to manually label every piece of information, the model learned by playing a kind of fill-in-the-blank game with sentences, teaching itself the patterns and nuances of language. This unlocked the ability to scale up training data to an unprecedented degree. 2. The transformer architecture. This is the engine that powers modern AI. It's a highly efficient and parallelizable design that allows models to understand the context of an entire sequence of data at once. This attention mechanism was the key to scaling up the sheer size and computational power of the models. With these tools in hand, the race was on to scale. Researchers discovered that as they made models bigger, they didn't just get incrementally better, they developed entirely new, emergent abilities that no one had explicitly programmed. They could suddenly perform basic math, understand multi-step instructions, and reason about concepts. This growth in model size has been exponential, far outpacing the famous Moore's Law. A chart shows a staggering 15,500x increase in model scale in just 3 years. The result of this power was the fastest adoption of any technology in human history. ChatGPT reached 100 million users in just 2 months, a milestone that took the internet 7 years and the cell phone 13 years to achieve. This user growth translated directly into some of the fastest revenue growth ever seen, with companies like GitHub Copilot and Midjourney reaching hundreds of millions in annual revenue in just a couple of years, with incredibly small teams. Chapter 2. A deep dive into the models. This chapter explores the technology and economics behind the AI models themselves. There's a fascinating paradox at the heart of the AI industry. On one hand, the cost to train a top-tier, frontier model continues to skyrocket, now exceeding $300 to $500 million for a single training run. On the other hand, the value of these expensive models depreciates at an astonishing rate. Thanks to fierce competition and the rapid advancement of open-source alternatives, a cutting-edge model can become obsolete, or at least matched in capability by a much cheaper open-source version within months, and sometimes in as little as 3 weeks. For years, the mantra was, "Scale is all you need." Now, the strategy is more nuanced. The industry is moving away from simply chasing the highest parameter count. We're seeing a trend towards smaller, more efficient models that are trained for longer, on higher quality, more diverse data sets. While these smaller models are less training efficient, they need to see more data to reach the same performance, they are vastly cheaper and faster to run for users, which is critical for real-world applications. A major challenge looms on the horizon. We are running out of high-quality data on the internet to train these models. The internet is finite, and much of its content is low quality. This has led to the belief that the era of pre-training as we know it is ending. The future will likely rely on synthetic data, using AI to generate its own high-quality training data. Reasoning and agents, building systems that can think, plan, and use tools to solve problems rather than just predicting the next word. The most exciting development is the shift toward inference-time compute, which is a fancy way of saying models that think before they speak. Instead of giving an instant answer, these models engage in an internal monologue, breaking a problem down into steps, weighing options, and refining their approach before producing a final output. This represents a new scaling law. We're discovering that a small model, given enough time to think, can often outperform a model 10 or 20 times its size that gives an instant answer. This is achieved through techniques like process and outcome reward models, training a secondary critic model to supervise the worker model's thinking process, rewarding good steps and penalizing bad ones. Search techniques, having the model generate multiple possible answers or lines of thought and using a verifier to pick the best one, a best-of-n approach. Multimodality. Models are no longer limited to text. They can seamlessly understand and generate images, audio, video, and code. While vision and language models are mature, true omnimodality is still in its early days. Robotics and science. The same foundation model concepts are being applied to the physical world. Generalized robotics models are now showing they can perform tasks in new environments, and DNA foundation models are learning the language of genomics. However, the biggest barrier in these scientific domains is the scarcity of high-quality data. Tokenization. A persistent, hacky problem in AI is how models see text. They break words into tokens, which causes strange issues with spelling, simple math, and understanding non-English languages. Training models directly on raw bytes instead of tokens may be a future solution. Chapter 3. Use Cases and Applications, where AI is making an impact. AI is no longer a niche tool. It's becoming a foundational layer for knowledge work across countless industries. Search and synthesis. The most prominent use case remains information synthesis. This goes far beyond simple search, allowing users to ask complex questions over vast datasets and receive synthesized, coherent answers. This pattern is being applied in hyper-specific domains, from legal research, Harvey, and investing, AlphaSense, to healthcare, Open Evidence. Software engineering. This field is undergoing its most significant disruption in decades. AI code generation tools are fundamentally changing the workflow of developers. For a quarter of the companies in one startup batch, 95% of their code was generated by an AI. This impact extends across the entire software development lifecycle, with new AI-powered tools emerging for code review, testing, documentation, and even autonomous software engineering. High-skilled professions. The revolution is spreading to all corners of knowledge work. Specialized AI co-pilots and agents are being built for accountants, Basis, 3D designers, Bezi, video editors, Sequence, electrical engineers, CADStrom, and many more. Creative expression. All forms of creative work are being reinvented. AI is democratizing video and animation, Runway, brand design, Visual Electric, and 3D asset creation, Meshi, allowing individuals to produce content that once required entire studios. Personal use. Beyond professional applications, people are increasingly turning to AI for personal support. Surveys show that therapy, companionship, personal organization, and learning are among the top use cases for general-purpose AI assistance. Chapter 4. Building AI Products. from models to systems. Applications have evolved through 3 stages. 1. Model in a box. Simply putting a chat interface on a model, example, early ChatGPT. 2. Retrieval Augmented Generation, RAG. Making the model smarter by feeding it relevant, just-in-time data from a knowledge base. This is the foundation of most enterprise AI today. 3. Agents, the current frontier. Agents are systems where the model can use a set of tools, like searching the web, writing code, or calling an API, in a loop to accomplish a complex multi-step goal. While the dream of a generalist agent that can do anything has struggled, specialized agents built for specific workflows, like automating software testing or customer support, are thriving. Think in systems, not models. The best teams don't just use a single model. They build sophisticated systems that orchestrate multiple, specialized model calls. For one problem, they might use a large model for planning, several smaller models for subtasks, and a custom-trained model for a final check. Retrieval is still king. Even as models can handle more information, larger context windows, RAG remains superior from most real-world tasks. It is far cheaper, faster, and more accurate than trying to stuff an entire database into a model's context. The best applied AI teams spend 10x more effort on their retrieval systems than on the models themselves. Context engineering is the new prompt engineering. The real challenge isn't just writing a good prompt, it's selecting the perfect slice of information to give the model. A simple coding query could have 1 million tokens of relevant context, related files, documentation, past interactions, but the model can only handle a fraction of that. Context engineering is the art and science of prioritizing, ranking, and compressing this information to give the model exactly what it needs to succeed. Evaluation is everything. In traditional software, you can write fixed tests. With agents that can take hundreds of different paths to solve a problem, this is impossible. The new challenge is building automated evaluation systems, often using other AI agents, to constantly test and debug these complex dynamic systems. Product and design matter. Too many AI products are just chat boxes. The biggest opportunities lie in completely rethinking user workflows. A key challenge is building a product today that won't be made obsolete by a more powerful model tomorrow. The smartest startups build around a workflow or a community, creating a defensible moat that isn't just reliant on the underlying AI. Chapter 5. Market Structure and Dynamics. The AI market is characterized by massive investment, unprecedented growth, and a unique set of economic forces. Investment frenzy. Venture capital is pouring into the sector at an incredible rate. In 2024, about 10% of all venture dollars went to foundation model companies. In 2025, that figure has jumped to over 50% of all venture funding. Hyper-growth. Companies at the forefront are experiencing revenue growth unlike anything seen before. OpenAI is projected to more than triple its revenue in 2025, reaching nearly $13 billion. Anthropic doubled its annualized revenue to $2 billion in a single quarter. This explosive growth is also happening at the application layer, with numerous startups going from zero to tens of millions in revenue in a year or less. Market dynamics. The big get bigger. This is an economies of scale business. Google, after a slow start, is leveraging its immense resources in data and computing to dominate the frontier of model quality versus cost. Moving up the stack. To survive, foundation model companies like OpenAI and Anthropic are being forced to become application companies. They are acquiring startups and building their own consumer and enterprise products because simply selling API access is not a defensible long-term business. NVIDIA is the guaranteed winner. Regardless of which model or application wins, they all run on GPUs. NVIDIA's dominance in the hardware layer has made it the primary beneficiary of the AI boom. Signs of a bubble.
The market feels bubbly. Training costs are immense, valuations are sky high, and many companies are burning through cash without a clear path to sustainable product-market fit. There is also a high risk of novelty effect revenue, where initial user excitement fades quickly.
Chapter 6. What's next? The AI native organization. This AI wave isn't just creating new products, it's creating entirely new ways of working and organizing companies. A new baseline skill. Using AI effectively is no longer optional, it is becoming a fundamental expectation for every knowledge worker. Companies are adopting a mantra of learn how to use AI or you will be left behind. The rise of the generalist. The value of hyper-specialized skills is decreasing as capable generalists, armed with powerful AI tools, can achieve similar or better results. This is leading to a profound shift in hiring. Companies no longer want specialists, they want smart, adaptable problem solvers who are experts at leveraging AI. The blurring of roles. Traditional job titles are becoming less meaningful. The lines between engineering, product, and design are dissolving as individuals can prototype, design, and even ship code using AI assistants. Managing AI fleets. A new and critical skill is emerging: managing fleets of AI agents. Just as a manager oversees a team of people, a CTO or product lead might now spend their day reviewing the work of dozens of AI agents, providing feedback and managing their tasks. Products built for AIs. A fascinating trend is the rise of products and infrastructure designed primarily for AIs to consume, not humans. For example, some database providers report that over 80% of new database instances are now created by AI agents, not human developers. Value destruction. As with any revolution, value will be destroyed as well as created. Areas most at risk include outsourced work that can be brought in-house with AI, e.g. marketing agencies, some consulting. Highly specialized roles and the tools that serve them. Middle management jobs focused on communication and information transfer. Incumbent software companies in creative and developer tools that fail to adapt. Chapter 7. What we're excited to see built. 1. The AI-first software organization. The proliferation of AI code generation will ripple through the entire industry. This creates opportunities for new tools to reinvent the software development lifecycle, from AI-native IDEs for non-coders to advanced testing and validation platforms that can handle the sheer volume of AI-generated code. 2. Modern data-as-a-service businesses. AI fundamentally changes our ability to collect, structure, and analyze data. There will be a renaissance of companies that use AI to unlock previously inaccessible information. Imagine using voice agents to conduct expert interviews at scale, or turning unstructured personal websites into rich, queryable user profiles. 3. Next-generation creative tools. The opportunity to disrupt creative expression is obvious, but defensibility is key. The winning companies won't just provide a model, they will build a complete workflow. This could involve creating new networks for AI-native creators, combining traditional editing with generative AI for precise control, or building the VS Code for video, 3D, music, an open editor with a rich plugin ecosystem that becomes the platform for a powerful AI copilot. 4. Data for AI. The data bottleneck is the biggest problem to solve. This creates opportunities for companies focused on 1. Simulation environments, creating high-fidelity virtual worlds to train and test AI agents. 2. Community-based evals, building platforms that harness the wisdom of the crowd to evaluate and rank AI systems. 3. Specialized reward models, offering best-in-class verifier and critic models as a service. 4. Vertical annotation, providing extremely high-quality human-labeled data for specialized domains like science or law. 5. AI and science.
there is a profound opportunity to apply generative models to the sciences. This includes building closed-loop AI scientist platforms that can generate a hypothesis, e.g., a new material, test it in a simulation, and iterate autonomously. In mathematics, AI could be used for autonomous theorem proving, making it possible to formally verify the safety of mission-critical systems like aircraft or financial networks. 6. Infrastructure for AI. As AI systems become more complex, they create new infrastructure needs, including 1. Multimodal data management, tools to handle the flood of image, video, and audio data. 2. AI provisioned infrastructure, the next generation of databases, APIs, and cloud services designed to be used primarily by ephemeral, serverless AI agents. 3. Infrastructure primitives for AI, rebuilding web primitives like search, browsers, and payment systems for an AI-first world. 4. Optimization of AI systems, building high-level frameworks that can automatically tune and optimize complex, multi-model AI systems, much like a compiler optimizes code.
That's all for this episode of Geek Capsule. We hope it gave you a fresh perspective on the world of technology. We'd love to hear your thoughts, so feel free to leave a comment or share your feedback. If you enjoyed the show, don't forget to subscribe and join us next time for another essential read. Until then, keep your curiosity sparked and your mind open.